following is a demonstration of one example of a common error in welding operations that can result in stray current flowing through a building's electrical system. Stray welding currents are dangerous conditions that can occur when the secondary welding current from the power supply returns to the source through unintended means, such as the building's grounding conductors. We are conducting this demonstration under very carefully controlled conditions, so as to not cause any permanent damage to our systems. However, it should be noted that this exact scenario has been observed happening inadvertently several times and at much higher currents than we will be using today. We will be using this SMAW or stick welding process today and this old model Hobart arc welder. The machine is plugged into a 3-phase 600-volt AC outlet and has an AWG number 4 power cord with an ampacity of 70 amps. The machine's model, current type, and process are irrelevant to the stray current events, and we have conducted similar tests on dozens of different machines and scenarios. Initially, we will demonstrate a correct welding setup where the current return clamp is properly located near the point of welding on the steel downdraft table. As you can see on the amp meter, we are measuring a secondary current flow of approximately 70 amps in the welding work and electrical cables as we weld. When using the amp meter on the power cord, we read 0 amps with both AC and DC settings while the machine is idling and when the arc is struck. This is normal as the AC current in the phases cancel each other out. Now we will repeat the welding operation after the welder has made the simple mistake of forgetting to connect the work lead to a point close to the welding area. As you can see here, the bare current return clamp has been left in contact with the machine chassis through the cart that it is sitting on. Many people are surprised by this, but in this scenario, the welding operation will work fine, and the welder could keep welding for hours and at a much higher currents than we are using here. The machine that we are using has a maximum output current of well over 450 amps, but we are only using around 70 amps today and for very short periods of time. If you are wondering how the circuit is being satisfied, the welding current is flowing from the welding machine secondary, through the electrode lead, through the work table, up through the ductwork, which attached to the building steel, into the building's electrical system, through the machine's power cord ground wire, through the machine's chassis, through the cart, and back to the secondary work terminal through the work lead. When using the amp meter on the power cord in this stray current event, we read 0 amps DC while the machine is idling, but the current jumps to 70 amps when the arc is struck. We are using a DC welding current here. However, we would see the same result with an AC welding current. This is not normal, and over time, we could cause serious damage to the electrical system. It is important to realize that the overcurrent protection devices in the electrical system do not react in any way to this stray current fault condition. Remember that the machine that we are using could easily be welding or carbon arc gouging at over 450 amps in the same scenario and for much longer cycles. Stray welding currents have led to very serious and expensive damages to equipment and electrical systems, and have been implicated as the root cause of serious industrial accidents, even resulting in death of workers. Electrical arcing in unexpected locations in a building can also start fires or explosions, since there is no way to predict where the current will find the path of least resistance through an industrial facility or construction site.